All right, everybody. So it could be a short stream today if people don't get some questions coming, because lesson is pretty self-explanatory today about serialization and specifically about how to use Jackson, which is a useful library for doing serialization. But anyway, certainly don't want to sort of talk through all the examples. But if you guys have specific questions about this, about anything that we've done this week, or just really sort of general stuff, I'm happy to take them. So I'm here for you for the next, 30, 40 minutes, depending on how things go. Ask away. This is an open Q&A time, and I will happy to discuss anything and everything today as part of the lesson walkthrough. So you are in charge. You guys must have something that you're curious about. So again, I'm here to answer any and all questions. So homework stuff, things about today's lesson, general questions, stuff about life that you want to chat about. Today is open to anything. It's a beautiful day here in Champaign. So if you guys would prefer, we could get offline and everyone can go outside and just hang out. So if you have questions, please ask them. Otherwise, we'll go outside and enjoy the weather. That's what we're doing, taking questions. Absolutely. Yeah, so the question is, are there libraries I need to install before I import? There are. And so far what we've focused on showing you are, yesterday when we looked at libraries, we looked at things that are part of the Java standard library. And so that you can usually find installed anywhere that Java itself is installed. So java.util, java.text, java.math, java.lang is actually java.lang is sort of imported for you. So you can almost think about it like at the top of every Java program, even if you don't import it, there's this implicit import of java.lang.star. So that's where you get string from. That's where you get math, the math static class that has things like absolute value and cosine and tangent and stuff like that. For other libraries, absolutely. So this is not something that we're going to get into on a lesson because it's not really something that we can get into using the playground. But we will talk about this once you guys start working on the project because, yeah, so the idea is, like let's say you want to use somebody else's library. Really what that means is that there are class files somewhere that someone has created and you need to get them to a place where your project can use them. And so there's a process of doing this. There's a bunch of actually different ways of accomplishing this. In general, when Java runs, it looks, and you ask it to import something, there's a particular set of locations that it looks in, and those locations are known as the class path. So there's a way of configuring when you start up the Java virtual machine to tell it a particular set of directories to look in when you want to import things. And so the idea behind importing a library is basically you need to get a hold of that library, and then you need to put it in your class path somewhere so that Java can find it when it runs. Now, you can do this by hand, but people typically don't. Instead, what they do is they use a variety of, this is sort of like build management or project management tools. One of them, again, we're going to show you guys on the project because it's used heavily in Android. And so the process usually goes something like, you find the package that you want to use. You figure out how to have the particular build system that you're using grab that package for you, a particular version. You add that to the configuration for your project, and then you can use it. Actually, since you asked, we might as well, other people aren't asking questions. Actually, let me walk you through the process of doing this just for fun. This is, totally off topic, but so let me go back and kind of reconfigure things a little bit here. Yeah, so let's look again at so remember a tic-tac-toe project that we did before? Well, you know what? I don't actually, do I want to do this? No, I don't want to do this way because this isn't set up properly. Hold on a sec. Let me create a new project in IntelliJ. There it goes. Okay. And hold on a sec. This import example. All right, let me make sure you guys can see this now. No, okay. I need to reconfigure this so it's working at the other project. Here we go, okay. So I've created this project using a build management system called Gradle. Gradle is a tool that you guys will, this is not something that we expect you to understand by the end of this semester. This is a very powerful, but also, in my opinion, somewhat confusing tool. But the reason that it exists is to allow you to easily import and it does a bunch of different things, but one of the things it helps you do is manage the dependencies for your project. So let's walk through an example of doing this. So let's, so I just created this little, so actually, you know what, let's go ahead and we'll actually kind of like do something that's similar to today's lesson. So I'm going to create a Java class called, we'll call this example, and then we'll show how to serialize a version of it. And so now, let's see, private int value, and then I'm going to use the fun features of IntelliJ to go ahead and just generate getters and setters for me because I'm lazy. I'll also use the fun features of IntelliJ to generate a constructor that sets that value. Check that out. I don't like this syntax. We can change it. So we'll do refactor, rename, call this set value rather than value. And then we can just do value equals set value. Perfect. And then same problem here. Refactor, rename, set value. and then we'll fix this. I don't like the default template for this because they use this explicitly. Okay, so now we have our example class. And now the question is, let's say I wanted to use Jackson to serialize this class. Oh yeah, that's okay. It's upset that it's not used, but we'll show how to use it in a minute. So again, let's say I wanted to use Jackson to do this. If I go back and let's just actually grab one of the imports from our example that we looked at today. So I'm just taking the import from the top of the playground, and now you can see that there's a problem. All right, and the problem is that IntelliJ is going to say, I can't find this particular library, right? And that's because in this particular project, I haven't told Gradle, the tool that I'm using to manage the project dependencies, that I want to use this yet. And so I'll show you how to do that. So actually, if we go over here, so this is the configuration file. This is a file called build.gradle. This has the configuration for the project, and I'm not going to go through everything in here, but the relevant part down here is this thing called the dependencies block, right? And what we need to do, let's see, is it implementation? I haven't actually done this for a while. So we're going to add a dependency to the project. And now what we need to do is look up, I'm going to look up the Jackson, let me switch back to the other view for a minute. Okay, so let's look up Jackson Java. And if we actually go back to this tutorial, let's see here, and the one that we were looking at was the object mapper tutorial. And so this is, so I said you need to add the coordinates to your project. This is something that, again, is sort of out of scope for us, although we might talk a little bit on the project. We will usually manage this for you. But the coordinates, the way that a lot of Java build tools manage dependencies is there are three parts. There's this group ID, there's the artifact ID, and then a version. And so if we actually, let's go back here. If we go back to our project, you'll see in this block right here, you see the group, the name, and the version. That group ID, artifact ID, name ID is the same thing that we want. So what we need to do, I'm going to just go back here and copy these. Well, you know what? I'll just show you what I'm doing in IDEA for a minute. I'm going to copy these from this into my project. So my group is named, so this, my name is, going back to here, and this is just simply me telling Gradle, which is helping me manage my dependencies, what dependency I want to add to the project, and you'll see that it's also versioned, so I can request a particular version of that dependency. Okay, so now this is in here, and now what I have to do is actually refresh it. Let's see here, did I do this correctly? Yeah, and actually now you can see how it's actually downloading the dependency? So now it's actually downloaded the dependency, and look at that. Now that package is available to me. Now that import is still grayed out because I'm not using it anywhere, but now we actually have access to it. And to see that, let's actually add, remember we did this before, we're gonna add a main method to our class so that we can run it. So I'll add a public static void main string unused. This takes some string arguments. And now what I'm going to do is let's just print something just so we know that this runs. So I'll run it now, and you'll see that it's going to think for a minute. Now it printed here. So now now we can, in this block, because this is what's going to run when I hit that play button over there, we can actually kind of go through that example we used again. And this will also show you how much easier these tools like IDEs make your life. We use the playground environment very intentionally throughout most of this class because I want you to get used to doing this stuff without a lot of extra help. But particularly when working with external libraries, the extra help's pretty helpful. So let's see how to do that. So what we're going to do is we're going to create one of those object mappers. So we'll say object mapper, and you'll see it's already helping me, right? It's helping me remember. And it will suggest names for it that are nice, and then I'm going to create a new object mapper. Now, what's the thing that I really like about working in this environment is that it'll help me remember what it can do. So look at all these different methods, and all I have to do is hit dot, and it starts pulling up these, like, all these different things that it can, it can do, right? Now, again, there's a lot of methods that are attached to this, and, sometimes it can be helpful. You usually have to have some idea of what you're trying to do, right? So in this case, we're trying to write value, and then you see there's this write value as string method that takes an object as an argument. And now I need to create the object I actually want to serialize. So I'll say example is equal to new example 10. And then what I'm going to pass in here is this example. And now what's it angry about? Let's see here. Oh, okay. There's the potential that this could cause a problem. I'm going to fix this by just adding this. That's fine. We'll talk more about exactly what's happening later. I hate Java. There's just so many forward dependencies in the language. It's difficult to do anything simple without it introducing lots of sort of complex stuff. So very briefly, this method can cause a problem. This method can cause an error to occur if, for example, like there is some problem formatting the output. And so what I need to do is just tell Java that can happen. All right, so now we'll say string JSON is equal to this, and now I'm going to print the JSON string. And now I'll run this again, and you'll see a string that's printed that's pretty much the same that we would have seen before. So again, this is an example of sort of like bringing a dependency into your project using this tool called Gradle. There are other tools that will do this. There's something called Ant that people use. There's something called Maven that people use. Gradle is I am not a fan, but it is by far the most ubiquitous Java build tool, and I think it's the one that's the most popular today. It's used by default by Android, which is one of the reasons that we use it. I use it for most of my projects. I fear it. I loathe it. I am always nervous about tangling with it because even doing very simple things with it always seems to be really hard. But it's what people use. If you're just looking at kind of like doing simple stuff, it's pretty basic. So again, in this case, what I've done is I've basically added so this file contains a configuration for the project that tells my IDE what libraries this project depends on. And what I needed to do before I could use Jackson was actually pull in that Jackson dependency. Once I added this, Gradle knew how to go out to the internet. It's looking in this particular location. I've told it to look in this location that contains a lot of different Java libraries called Maven Central. And so what it did is I told it here, hey, in order to compile this code, I need this external dependency. The group is com.fasterxml.jackson.core. The name is Jackson Databind, and the version is blah, blah, blah. I told it where to look for it. I said, please pull this down from Maven Central, which is one place. It's an online repository for lots of different Java packages. And so when you saw me refresh the project, what Gradle did is it said, okay, you need this thing. I don't have it yet. I'm going to go grab it. I'm going to configure your project to use it. And then that import error immediately went away. And if I needed another library or another library or another library, I would have to keep doing this, to add any libraries I need. Now, like I said before, the basic Java stuff is built in. So if I want, let's say arrays dot, right? If I just want arrays, if I just go like this, I automatically get it, right? And then I could say arrays dot whatever and use any of the array utility methods. The stuff that's in the Java standard library does not need me to add a dependency to that build.gradle file because it's there by default. So yeah, great question. Let me try to figure out how to get back into get this reconfigured again. Okay, sweet. Yes, see, it's a really good question. Let's see the other questions. Yeah. Yeah, I mean, whatever. Yeah, so this is Gradle is in many ways like pip. I think Gradle does more than pip does because Gradle will do a lot of different things for your project. So again, once we start working on the machine project, Gradle is in charge of determining things like building the entire project. So at some point, if you wanted to like publish your project to the Play Store or whatever, that requires taking the whole thing, which includes lots of different files and different pieces, and basically kind of packaging it all up together in a particular format that Google has established for creating Android apps, and Gradle doesn't necessarily know how to do it, but Gradle can be told how to do it. Whereas pip, I think, seems to be primarily for managing external dependencies, but it's not a bad comparison. It's like, if you need an external dependency in Python, you stick it in this pip file, and then you run it or whatever. I think Python's handling of external dependencies is a mess, but that's okay. It's just me. Well, anyway, about Java. I mean, Java, the thing with Java is like it's a very mature, powerful language, and so like it's hard to do anything simple, right? Because it doesn't allow you to get away with certain things, right? Like we saw with the exception, right? It's like, oh no, something could go wrong, and so it forces me to do this weird thing. And I think if we were trying to do this like in the first week, people were like, oh my gosh, there's so much syntax there I don't understand. So it's hard sometimes in Java to work incrementally. Okay. So for puzzles like the previous Sudoku or tic-tac-toe, how do you come up with all the edge cases and skeleton of the entire class? I would say you go. There's no magic to this. You go step by step. When you're building something, the usual trick is to get 90, get the stuff that needs to work, and then start to think about some of the ways that things can go wrong and different ways to protect against that. One of the things that I do, and we'll show you you guys aren't going to get to do this necessarily, but when I'm building stuff, I write tests. Right, tests are usually how I get the program to do something. And so if I want to show that the program can do something, I write a test that tries to get it to do that thing. And then if that test succeeds, I'm like, okay, well, that's something that this tool can do. And if the test fails, then I'm like, okay, well, that's something that this tool can't do yet. And then I go about fixing that. To me, at least, like in many cases, the tests that you write for a project end up being an embodiment of what it's capable of. Right? I always say, like, if I don't have a test case for it, I don't know if it can do that thing or not. Maybe it can, because maybe I've already actually done that. And so when we find problems with the tools that we use in this class, the first thing I always do before I fix it is I write a test case that exposes the problem, right? So you guys find a bug on something, or there's a homework problem that has an issue, I'll always take, a test case. So sometimes that's why I'll ask people on the forum, like, send me a PM with your code, because I actually have test cases. I have edge cases that are built into the homework grader that are based on potential solutions or things that shouldn't be solutions. And so I can stick the code into our project and say, okay, well, this should succeed or this should fail. And then I can sort of test our auto grader to make sure that it works properly. So that's something that you do. But, you work incrementally. The way to solve a big problem is you're never going to solve a big problem all at once. You have to break it down into smaller pieces and work on them one at a time. So let's see here. And when you guys, this is not something that we teach you how to do in this class, but in future courses, although maybe we'll do. I'll at least do some screencasts as part of the project, showing you guys how to do this a little bit. Writing tests is, so there's this question of like, how do I make the program do anything, right? How do I know that it does anything? And particularly once you start to work on a big, complex program, you don't want to test it by running it. That's too slow, right? Like imagine you're working on an Android app and, you're trying to add a new feature to one screen. You don't want to have to like run the app and log in and navigate to that screen and like click the button every time just to have it crash, right? Like that's really slow. And so typically what you find ways to do is to isolate the part of the project that you need to test and write a test case for it, so that you can repeat that process very quickly and very easily. Or you kind of separate it out. So like you separate out the part where the button gets clicked from what happens afterwards. And so if I have let's say there's some function that runs when a button gets clicked, which is pretty much what happens, I can test that function without clicking the button, right? And now, as soon as that function or that method works properly and seems to do what I think it's going to do and doesn't crash, I don't worry as much about the UI part, because I know that as long as I connect the button properly to the action that's supposed to happen, it's going to work out okay, right? It's not always that simple. Sometimes the interaction between your UI and your code is a little more complicated, but it's yeah. So the test cases for the homework. I mean, so one of the things we do to test your code is that we don't write test cases by hand for the homework. That's really tedious. So typically what people now when you're and again, grading your homework is not a typical type of testing problem, right? Usually when you're writing your own tests, you write like one case that you think should work a particular way and then you test that, right? When we grade your homework, we have an advantage that most people that write tests don't, which is that we have what's called a reference solution. We have code that embodies how we think your code should work. And so we actually don't write down a bunch of test cases and what we think the output is. What we do is we automatically randomly generate a bunch of inputs to your method. So think about it. I have your method and I have the solution method. And testing a class is a little more complicated than this, but it's not that much more complicated. So if I have your method and a solution method, imagine it's a static method, so there's no instance I need to worry about. What I do, and let's say they take strings, okay? So what I do is I generate a bunch of random strings. And then one at a time, I call the solution method and I call your method and I compare the results. And at some point, if your submission deviates from the solution, we consider it to be incorrect. And that's basically what we do. So there's no file that has all these test cases written down. This system is new. This is something that we built last summer. And the reason was we never had test cases written down, but we had testing code that would kind of generate the test cases using random numbers and things like this. But it was getting difficult to maintain. And so what I proposed to some of my course developers is I said, hey, this is kind of a unique problem because most of the time, like I said, when you're testing code, you don't have a solution. If you had a solution, you wouldn't be writing the tests, right? You're writing the test because you're not sure if the code works properly. So if you have a piece of code that works properly, then you're done. So this is a weird problem. Like there's a lot of places where normal software development and the types of things that we do to grade your code in an intro class overlap, but this is something strange, right? During normal software development, I don't normally have correct code that I know is correct, right? And then code that I'm not sure about, right? Typically, all I have is code I'm not sure about, and I try to write tests to allow myself to be more sure about it. But in this case, because we have a reference solution, we can use this kind of unique approach. This isn't, so I guess there are some cases when you would write real tests. So here's an example. Sometimes people have a part of their code that gets too slow. Let's say I have a method that needs to perform some algorithm, and I've realized now, that method is taking a long time and it's causing things to get slow, and I've got users complaining and stuff like that. So I need to re-implement it to be faster. Well, now I might have a reference solution because I've got a slower version of the function, and what I need to write is a faster one. And so I could have a case in real life where essentially what I'm doing is I believe that the slower algorithm works properly, but I need to optimize it. And so I could write tests that basically test to make sure that my optimized approach is faster and also produces the same output. But that's not super common, right? It's more common, like I said, to have code that you're not sure about. You're never sure that it's totally correct, and you have test cases that help you establish correctness. So in our case, we have code that we are sure is correct, and we need to figure out how to test your code against it, right? So it's a little bit of a unique problem to sort of auto grading in a classroom type setting. And so now the thing that's cool about this that I'm really happy about is that, so in the past when I wrote homework problems for the class, I had to, most of the time went into writing the test suite, right? So you come up with the problem in 5 minutes, right? And then you spend several hours writing the test suite and trying to make sure it's correct. Now, all I have to do is write a solution, and that's typically quick. And then this new tool that we've built will automatically do all the rest of the work for me, which is nice, right? So it's actually allowed me to write homework problems a lot faster, which was the goal. Now, we're making new kinds of mistakes this semester. Obviously, a bunch of the homework problems have had small issues with them. So the one thing that no computer can check is does the specification for the problem, the English language description, match the solution? If that's wrong, then no amount of testing automation will help you, right? If I tell you to solve a different problem than the one that I've solved with the reference solution, then we're in trouble, right? In other cases, like, there are, again, sort of irritating bits of Java that get in the way. So on yesterday's problem, which was on the date formatting, the reference solution was using instant. So basically, if you create an instant, you can create an instant from a long, and then you just call the toString method. Well, so I thought that output stuff in a consistent ISO 8601 format, which is a well-established format for datetime. And so that was the problem specification originally. What I didn't realize until later, which is super irritating, is that the instant will print. So originally what the test suite was doing is it was just comparing the two strings, right? Your output versus the instant output. What I didn't realize is that the instant output will actually add it adds a certain number of milliseconds or microseconds depending on the precision that it needs. So if you give it like 0, it will print, January 1st, 1970, but with no fractional seconds. And then if you give it other numbers, it prints like either 3 fractional seconds or 6 fractional seconds or even 9 fractional seconds. So there were other approaches that used a different approach with like a date formatter, and those didn't work because in that format you have to tell it how many milliseconds to output. And so eventually I decided to just go ahead and fix that. So we modified the test suite a little bit. So instead of comparing the strings, what it did is it actually used those strings to compare new instances of instant, and then compared them to see if they were equal. And so that allowed some other approaches that I wanted to work, right? I mean, I don't want you to get points off for doing it slightly differently. But again, that's one of those places where just like, Java itself sort of gets in the way there. I don't know why they do that. I think it's really dumb. I think it should have a consistent output format. If you don't need, if you have zeros, just print the zeros, right? Because it makes it very, very difficult to replicate using a date formatter, because you would have to examine the date first and figure out how many zeros to include in your format string, and that's difficult to do. So anyway, Java. Other questions? Yeah, I mean, the projects I'm working on right now are pretty much stuff that's related to the class. So, the homework set you guys are working on, I mean, those are a mixture of old problems that we've used in the past, but then we have this new testing approach, and so I've been sort of importing them into that. We're working on getting the machine project ready for you guys. That's something I'm working on. Building the website and putting the lessons up. The functionality of the website has been pretty static for the last few weeks, but there's some new features that we're going to have to add over the next few weeks, like, giving you guys a simple view of your grade in the class, and once we start the MP, being able to see the output of the MP test and stuff like that. So there's some new things that we'll have to do there. But yeah, I mean, the main sort of Java-related projects are all sort of class-related things, right? Like the library of small problems, the testing tool, and then the playground runner as well, right? Because that's not a new tool. That's something we've been using now for, I'm trying to think, over a year. We kind of put that together in summer 2018 and used for the first time full-time fall 2019. So that's a couple semesters old, but we have actually found some new bugs in it. Or not always bugs, but like limitations, right? That we have wanted to fix. So different solutions. I mean, look, if you submit stuff that passes the tests, we know that, right? So yeah, I mean, we can always go through and pull those out of our database and stuff like that if we wanted. Typically what I'll do, like if you have a solution that works, then that's fine, right? The time to get a hold of us is if you have something that you think is correct that's not being considered correct by the auto grading, right? In that case, maybe it's wrong, or maybe the grading is a little bit too narrow, right? Like I said, that was kind of what was happening with the datetime formatter, right? And that there were solutions that produced valid output in the correct format, that weren't being considered correct by the auto grader because of these small string differences. And so we fixed that early on in the day. But yeah, if you have stuff that's passing already, then we're good, right? If you, like I said, if you have a different approach to the problem that you think is correct, but the test suite is not considering to be correct, then by all means get in touch with us, because we'd like to. So again, what I typically do is I take that code, I add it. We have a way in the homework project where we have all the homework problems to basically add in alternate solutions. And so I'll add it in as an alternate solution. I'll rerun the test suite for the test suites on the homework problems. And if it barks at me and says, well, this thing that you told me was correct isn't correct, I'll have to think about kind of like how to fix the grader so that it's correct, right? So that it accepts all possible solutions. But I think so far we've been pretty good at that, right? Like I said, the tool is new, right? And I am really sort of happy about the degree to which it's accelerated the process of writing homework problems. I think that I'd like to get to the point in this class where we have a library of like several hundred homework problems that we use throughout the semester. One of the things that, people that are getting started often ask for is like, I'd like to have more problems to solve. So I'd love if at some point every lesson had like one required homework problem and then maybe like 2 or 3 or 4 or 5 alternate homework problems that you could also work on or solve if you wanted more reinforcement of that concept. And it just comes down to being able to write those problems faster. And in the past, like having to write a separate test suite for every problem was really, really slow. And we're to the point now where pretty much, it's pretty close. Like all you have to do is write a solution and our test harness does the rest, right? That's not always the case. There's some places where you have to help it a little bit, and there's some ways to do that. But like the goal is to just make it, and I think it's been working, right? I mean, when I wrote the original set of homework problems, that was 2 years ago. That's kind of all I did that semester. Like I had the rest of the class kind of prepared, and so most of my time every day went into authoring those homework problems. And now I can kind of like knock them all out in half a day on the weekend for the entire week. So that's a substantial improvement. How do we know why our code in the exam quiz failed? Yeah, so I mean, the output from the autograder is as descriptive as we can make it. If you have suggestions that you think would help, and that's something that, to be honest, I think has also been a big improvement. In the past, the errors produced by testing can be really difficult for students to understand. So let me give you an example of this. Let's say that let's say that we ask you to write a function called like bar, and you write a function called foo. What happens is when we actually go to grade your code, the test suite is going to try to call a function called foo, right? Bar, because that's what we asked you to write. When you write foo, what happens is when we try to compile your code, the test suite fails to compile. And so the errors you get are actually from the test suite failing to compile. And students were always confused by that. And I get it, right? It makes no sense. It's like, they'd be like, oh, your test suite's broken, it didn't compile. It's like, no, it's not, right? It is your fault, right? In the sense that you wrote the wrong method. But because the errors would come out of the testing suite, it would be very, very difficult for people to understand. And so now you get a much, much better error message, right? Because now it says, you didn't provide this method. And I think that on its own has been helping students a lot, kind of like figure out. This weekend, we actually have, we're actually going to give you guys a chance to really kind of exercise that capability, because the weekend homework problems are essentially reverse engineering challenges. So we're not giving you the problem description. I'll give you some hints on one of them because it's a little tricky, but essentially we're just giving you the grader. And it's your job to figure out like what you need to do. And I'm going to record a walkthrough to get you started on that. But basically it's kind of like, your job is to bang on the grader to get a sense of what it wants, right? And there's no description. So it's just, so you can imagine, the first thing you do is you just have to, we don't even tell you what the class name is. So you just submit some class with any name, and it'll tell you, oh, here's the class that you should submit. It's like, okay, now I know what to do, right? And then what method should that be? And then you can like a method will return something and return null and see what happens, and it'll say this test case failed. And so you kind of work forward one at a time until you figure out kind of what the class or the method needs to do, right? So that's usually kind of fun for students and tricky, right? But there's a method to it, right? And so we'll give you some practice with that. But I do think that the homework grader that we're using this semester is producing much stronger output messages than it used to in the past. Yeah, and I do that too. I mean, that's totally fine. I mean, and that's, on some level, that's something that, an IDE typically really helps with, right? Because it'll do things like autocorrect and make it much easier to rename things. And so I haven't had to me, I think providing those sort of hints is not a problem. And I hope that people are not, it's always a trick, right? Like, are you, maybe we shouldn't be providing as descriptive messages, because I think you almost cut and paste the method description from the error message into your code and just keep going at that point. And obviously in the future, you need to be able to actually read the problem description and figure out what needs to be done based on that. Most test suites that you will use are not that kind, shall we say. They're not that. They'll just give you some strange error message. It doesn't make any sense and be like, so. I think we'll get to the point where we will we'll let you guys see more of the output on your quizzes. This just this is the quizzes this semester are really very much more an evaluative tool, right? The goal, to be honest, what happens during the quiz to me is not particularly important, right? It's what happens before the quiz, right? The preparation you guys do, the practice you guys do. You could go in the quiz and get all the questions wrong, but you still have learned, right? You make small mistakes, and sometimes those have, bigger consequences than others. But if you did the work, right, the quizzes are an imperfect measure of how much you really know about how to do things. But they're a very good forcing function to get students to practice. So again, I just, it's not that, I understand you get something wrong, you care about what happened, you want to, see what you did wrong and things like that. But on some level, like what you did wrong under those very specific timed conditions is not particularly meaningful, right? The way you do things wrong with the quizzes is when you don't prepare. And so the quizzes are there to push that. All right, any other questions? Yeah, I mean, with respect to Java, I don't know. I'm not, Java's a perfectly fine language. It's a well-established language. It has some nice design patterns. There are some things about it that annoy me. I'm not going to lie. But when I started teaching this class, I was more skeptical about Java, to be honest. That was 3 years ago. And I've made my peace with it, in the sense that I think I understand kind of what's good about it. And I think we have a reasonably decent approach to teaching it that tries to avoid some of the, big rabbit holes that you can fall down, and the places where things can get tricky. But overall, yeah, I mean, I don't write a lot of Java code left to my own devices. I think there are some other languages that are improvements on it at this point. But it's also nice to see it moving, right? I mean, getting yeah. I have to see more about exactly what, So that the exception error message will have a line number on it, and I'll tell you exactly what line through that message, through that. So you should be able to look at your code and be able to figure out pretty much exactly where that error came from, right? I mean, the error, again, it has a line number on it, right? That line number corresponds to the code that you wrote. So whenever you have an error message in Java, whether it's a compiler error or a null pointer exception or anything like that, there are two hugely valuable pieces of information contained in that error message. One is the location, and the other is what it is, right? And so you have to use those two together, right? If the error message says it's on line 8, go to line 8 and look at it, because that's where the problem is. And so, yeah, and so when you get that message, it means basically like because there are times when we expect your code to throw an error, and we'll get there later in the semester. We'll actually do some work with exceptions, but for now, so that typically is a sign that something went wrong. And again, that message has the location of the error message right on it, right? And that's by far the most useful piece of information there, right? And probably what's happening there is that you haven't actually, so you can get null pointer exceptions with, this is a good question, right? So you can get null pointer exceptions with arrays quite easily, actually. Let me go and show you how that happens, right? So let's say that I say, course is equal to new. Well, I need to say let's see, private. I'll make this public. Public string department course. I'll make this 8, and then I say courses 0 dot department is equal to foo. Boom, there it is. And the problem is there's no course object there, right? Remember, the array of courses that we create contains I like that question. I'll get there in a minute. The array of courses contains references to courses, but I only created the array. I never created a course object here. No, it's confusing. There's square brackets instead of round brackets, but this creates an array of references. Those references are null. So if I look at, sorry, the cat's tail is on the keyboard. She's here helping me today. It's null, okay? And so when you do this, it's null. You gotta create a course object somewhere, right? So if the first thing hey, I know you're trying to help. If I create a new course, and then I say, I need semicolons, yeah, that's right. Then I'm good, right? Then I don't have that NPE. But that's I think what's getting a lot of people today, right? The course, but again, that message is in your code, right? So, use the information that's provided in those error messages to help you, right? I mean, it says on this line you had a null pointer exception, so don't claim that I don't know where the problem is. It told you, right? And that's incredibly useful. So you go back, you look at that, and you kind of get, yeah, exactly. You have to actually, well, they're not instants, but you have to fill the array. So that's a good reminder. The daily assessments, yeah, I mean, there are other courses in the department. I think 101 does daily homework problems. Maybe not 105 does. To be honest, it's sort of weird. I think there's a lot of people that don't think that that daily lessons are appropriate. Daily homework problems are appropriate for students to do. This came up on this sort of forum I was on recently, where one of the students was talking about the courses they were taking. They were like, "Oh, I do these," and the course has us do these daily homework, and it wasn't 125. I think it was 101. And the person running it was like, "Oh my gosh, daily homework problems?" And it's like, do you want to learn the material or not, right? I mean, if you want to run a marathon, you go out running every day, right? If you want to learn an instrument, you play every day. If you want to learn to read, you read every day. If you want to learn a language, you speak the language every day. I mean, I don't know why that's so weird, but I think there's this idea, I think there's this very old-fashioned idea of college where it's like, I give you a term paper and you work on it for 3 months, and then somehow you're supposed to learn stuff that way. And I think at a certain point, you have to be able to do that, right? There's a certain point at which, you have to be able to take something that's big and break it down into smaller pieces and be diligent about it. But I think the way you learn how to do that is by having somebody help encourage you to structure things that way. I mean, when I was a kid and I was learning how to, play a musical instrument, I mean, my mom made sure that I practiced every single day. Not necessarily for a long time, half an hour, 45 minutes, an hour, as I got the ability to concentrate more. It's so funny. I mean, I remember myself at that age, and I could barely sit still for 30 minutes. I would be like, jumping up, checking the clock. Oh, it's only been 24 minutes, so okay, I gotta play a little bit more. Play a little bit more. Jump up, check the clock. Oh, it's been 25 minutes. It's like but it helps. So I think that we've been there's a new course that's coming online that's going to be a follow-on course to 125 that eventually everybody in the department is going to take. I think that course will still use a very regular lesson and assessment model. And then at some point, I think once you start to understand that that's a part of how to learn the material, you can sort of start taking those training wheels off and have you guys do bigger things that take more discipline and more more self-discipline, right? More sort of like scheduling. But I think that, having some encouragement to get things set up that way is good. But again, I think the new course 128, I've been talking with the instructor and I've been encouraging him to do something similar. 225 has these problems of the day, right? So they're extra credit, which I think is a little whatever. But yeah, I think that this is, on some level, this is a skill. This is a course that teaches both knowledge and a skill. And when you're learning a skill, regular practice is really the only way to learn it. You just can't cram this stuff, right? And partly that's, if you think about it, that's because of how your brain works. When you're building new neural pathways in your brain, which is what you're doing when you learn this material, you've got to kind of like exercise them and then let your brain adapt, right? Let it heal, let it rebuild itself, right? And then you come back to the next day and those pathways are a little fresher and you kind of rerun some of those same things again, and then you take it off. Doing 4, 6, 8 hours of this at a time is not as effective from a learning perspective as doing an hour of it every day. You have to let your brain adapt to this new information and start to kind of like, rearrange itself. So yeah, so I hope that we see more of that, right? And I think that there's just there's a little bit, like I said, of a reluctance to embrace this as a model. I'll still talk to colleagues at some other institutions. I'm like, we do these daily homework problems, and they're like, oh, so students can do them all on the weekend. I'm like, no, they do every day. And I think some people are really surprised that there isn't more pushback about this. But I really agree. To me, I think this is one of the more effective parts of the class, is just making sure that you guys come back and are encouraged to do a little bit every day. So. All right, I'm done for the day. I hope you guys have a wonderful weekend. It looks like it's beautiful out. Enjoy the weekend homework problems. I think they're fun. And we'll be back together on Monday. And next week's topic is really cool, so I'm looking forward to that. Have a great weekend, and I'll see you then.